In this video, we are going to be looking at place value together. Now, the history of numbering and counting in mathematics is interesting. The way it evolved from our four great-great-grandfathers till today. Now, for example, in the ancient days, people usually count with stones and probably rods, things you can see. Then we moved to what we call the tally system. And this were the ancient people counting on caves and rocks. In the tally system, they basically used strokes to count. For example, 1 stroke stands for 1, 2 strokes for 2, 3 strokes for 3, 4 strokes for 4, then 1, 2, 3, 4, another stroke to cross it for 5, etc. But you can see that we get into problem when we want to, for example, represent 1,000 with strokes. How do we count 1,000 strokes? It's burdensome. And so we move from the tally system to other systems of numbering. And at the time we got to what we call the Roman numerals. Now, the Roman numerals was a great advancement over the tally system because we now have symbols representing each number. For example, 4 is represented by IV. Then we've got, say, 10 is represented by X. Then we've got C is 100, D is 500, M is 1000. Do you understand? But there still was a problem with this because even though I know that 4 is IV, for example, if I wanted to do 4 plus 4, there is no way I can actually do it on a paper in which I can see it. I can't do IV plus IV. It doesn't make sense. So we needed to evolve the Roman numeral system of numbering. And then we got to what we call the Indo-Arabic numbering system, and that is what we use till today. So these are 1, 2, 3, 4, 5, 6, 7. All these is known as the Indo-Arabic system of numbering. Now this I hope you know. Do you understand? With the introduction of the Indo-Arabic numbering system, we now add what we know as positional notation, which is what we are learning today, or a part of what we are learning today, and then the invention of 0 as a placeholder. Now, what I mean by that is this. For simplicity's sake, I'm not going to write the place values yet, but just think of the place values as these boxes that I'm drawing. Now, if I put 1 under this box, it means something. If I decide to put 1 under this box and put 0 as a placeholder, it means another thing. If I decide to put 1 here and we have 0, it means a different thing. And then if I put 1 here and then I put 0, can you see this means 1? This is 10. Let me write it in words. And here we have 100. And here we have 1000. Can you see, by putting 1 in different positions and making use of the placeholder, which is known as 0, we're able to get different numbers still using the same 1. Does that make sense? And this makes computation very easy, because if I wanted to do 1 plus 10 plus 100 plus 1000, I can do it just immediately. 1, 1, 1, 1. Do you understand? So this is the importance of the place value system. Now, I just did a brief history of the place value system from what used to be and what we now are, so that you can really understand the importance of treating this topic. Now, let's go to what you really need under the scheme of work for this topic. Now, the first thing you need to know is that we've got names for each position in the place value system. The first position is known as the units, followed by the tens. Then we have hundreds, followed by thousands, Then we have tens of thousands. Then we have hundreds of thousands. Then we have million, followed by tens of million, hundreds of million, then we have billion. So let me write billion. We have tens of billion, hundreds of billion, then we have trillion. Definitely it doesn't end here. We still have tens of trillion, hundreds of trillion, then we can have a quadrillion, and so on and so forth. Do you understand? Now, for the sake of simplicity, we are going to represent units as U, tens as T, hundreds as H, thousands as TH, tens of thousands as TTH, hundreds of thousands as HTH, million M, tens of million TM, hundreds of million HM. Do you understand? Then we have billion B, tens of billion TB, hundreds of billion, we have HB. Then trillion, we can represent it as TR. Do you understand? Now let's take an example. Now we are told to find the place value of the numbers below. Alright, so let's do this. Now remember, the first digit would be what? Units. The next would be what? Tens. Followed by what? Hundreds. Then we are going to have what? Thousands. Followed by, now after thousands, the next will be tens of thousand. So we have tens of thousand, followed by hundreds of thousand. Do you understand? Then the next will be what? Million. So we have million. Then after million, the next will be tens of million. The same way you did after thousand, tens of thousand. So we should be having tens of million. Then followed by hundreds of million. So we have hundreds of million. Now after hundreds of million, the next would be billion. So we should have billion, billion. Then followed by tens of billion. So we have tens of billion. After tens of billion, what would we have? Hundreds of billion. Hundreds of billion. Then lastly, we will have trillion. Do you understand? So units, tens, hundreds, thousands, tens of thousands, hundreds of thousands, million, tens of million, hundreds of million, billion, tens of billion, hundreds of billion. Then lastly, we have trillion. Does that make sense? Alright, let's take another example. Now we have this question. What's the place value of 8 in 8576? Now this is like an exam question. The other question I gave you previously is just for you to be able to see all the place value in a glance. So let's do this. We write the number first, so we can have solution 8576. So we can go. Now the reason I'm doing this way is because when we go to an advanced level of place value, it becomes much easier. So the first digit will be units, second will be tens, third will be hundreds, and then fourth will be thousands. Can you see? So it means that our answer is what? 8,000. So we have 8,000. Sometimes you could have just 1,000 in the option, or you can have 8000. Can you see what we did? The place value of 8, so we write 8, and then the remaining we turn them to 0. Do you understand? Now if you see any of these three options is correct, so either 8,000, 1,000, or 8,000. Do you understand? Can we take another question? Now we have what's the place value of 5 in 3450020. Now remember, you just write it 0020. Now the first will be what? Units. Second will be what? Tens. Third will be hundreds. Fourth will be thousands. Then fifth will be tens of thousands. Now we really do not need to do others, since we were asked for the place value of 5, but this would be hundreds of thousands and this would be million. Do you understand? So it means that our answer would be either tens of thousand, or we can also have 5 tens of thousand, or we can have 5, you write 5, and then turn the remaining digits after it to 0. So we have 1, 2, 3, 4. So 4 zeros. Do you understand? So you see that tens of thousand, or you put 5 tens of thousand, or you write what you were told to find, and the remaining digits after it will be turned to 0. Does that make sense? Now we have what's the place value of 7 in 2407. Now let's solve this. So we write the digits given, or the number given, 2407. Now this would be what? Units. Now since it's the place value of 7 we were asked to find, we can just stop here. So our answer would be 7 units, or just units, or we just write 7, because there is no digit after 7, so it will just be 7, or it's either we write units or we write 7 units. Do you understand? Now another question you could be asked is this. Let's take one more. Now this question says, what is the sum of the place value of 2 and 1 in the number 4219? Let me note that this is a National Common Entrance Exam question. So let's solve this. Now remember, we have 4,219. Alright, so what is the sum of the place value of 2 and 1? So we can have units, tens, hundreds. Do you understand? So it means that for 1 is 1 tens. 1 tens, so we can write tens, or 1 tens, or we can write 1 0. Remember, the digits after what we're told to find will turn to 0. And then for 2, we can have hundreds or 200, or we can have 200, because the digits after 2 will turn to 0. Now we're told to find the sum. What's the meaning of sum? We add. And what can we add? We can add this 10 with 200. So it means that the answer would be 200 plus 10. And 200 plus 10 equals to what? 210. Do you understand? Now that's why you need to know these 3 ways in which we can represent the place value of numbers. So don't forget, in this video we've taken the various representation of place values we can have: units, tens, hundreds, thousand, tens of thousand, hundreds of thousands. Then we have million, tens of million, hundreds of million. We have billion, tens of billion, hundreds of billion, and then we have trillion. Do you understand?